Everybody, this is going to be Wednesday. I'm going to be doing a video over exponential functions. So this is going to be the last type of graphing and type of equation that we talk about in algebra. We've done linear, which means it's going to be straight lines. We've done quadratic, which means it's going to make the U shape or the parabola. And now we're going to talk about exponential, which is going to be a much shorter unit and a much more confusing unit, because we're now going to be making our variable x be the exponent, which means that everything's going to grow really, really, really fast. So I want you to understand that before we start this video today is very, very, very basic introduction. We're working towards domain and range, but with this being a shorter week, I decided to make tomorrow a review day over just extra material. So today is going to be your video, and then you guys will have your review tomorrow, and then you'll be off on Friday, off like you're not already off from school every day. Saturday, Sunday, and then coming back Monday, we'll pick back up with exponential. So again, today is just an introduction. Please do not stress if you're confused about some things. Just be patient. We're going to readdress it all. I'm just trying to give you a basic introduction today so you have something to kind of think about going forward. All right, with that being said, let's get started with the video. Okay, so this video is also going to be a little different because I'm going to be recording a lot of stuff from the book. The reason I'm doing that is because there are a lot of visuals that I want you to see, and so that's how we're going to do it this way. So it won't be a lot of writing down, just a lot of actual pieces from the book. So first, what we're going to talk about the vocabulary, and we've got two words based that I want to talk about. One's asymptote, and that's going to be a line that as this graph gets closer to the x or y. And then we're going to have exponential function, which means that an exponential function is a function in the form of, there's our formula, y equals a times b to the x power, where a is not 0 and b is greater than 0, but b cannot be equal to 1. Yeah, I know, confusing, but I promise it'll all make sense. So I'll give you a second to jot those down. Feel free to pause this if you need to. Okay, so right here, we're talking about what does an exponential function look like. So I want to just review here that we talked recently about linear equations always form straight lines. Well, notice that these are not straight lines. They are functions, however, because we're not repeating any of the x values with a y value. But notice that they kind of make this nice little arch type of deal, and one part of that line gets really, really, really close to the x-axis over and over and over, and then the blue line gets really, really, really close to the x-axis again, okay? This is what we call an exponential function, and once again, we can see that the formula is y equals a times b to the x power, where a does not equal 0, and b has to be greater than 0. Well, the reason a cannot be equal to 0 is because if a is equal to 0 and we're multiplying a times b to the x power, well, 0 times anything is going to make it become 0. And b has to be greater than 0, because if b was less than 0 or equal to 1, then it would not create enough growth on that line that it would just be stagnant. So just be aware of that a can never be 0. A is still going to be kind of our determining factor. Depending on what number a is, determines which way the line's going to go. And then the tricky part right here, though, is notice that our x, our variable, is now the exponent. Well, when we think about exponents, just as a refresher, exponents are when we multiply something by itself. So if I'm taking a number and multiplying it by itself, it's going to increase at a much, much, much quicker rate, which shows why these values are increasing so much faster, why this line is growing at a very quick rate. Okay? All right, moving right along here. So I showed you a silly word with our vocab a few minutes ago, and that word was asymptote. And asymptote is basically going to be which line, either the x-axis or the y-axis, depending on which line it gets really, really, really close to. Now, I'm going to try to explain this, and it's going to be harder without giving you graphics, but hopefully we'll be able to get to that. Notice that this line is getting closer and closer and closer to the x-axis as we go forward. Well, because it's getting closer, we're assuming that eventually it's going to hit the x-axis and become 0, or maybe even drop past the axis. But notice that the line is staying right on that axis. It's just becoming a really small decimal. So it's like 0.0004, 0.000004, all the way, all the way, all the way. But because the a value can never be 0, we can never actually achieve 0. We're always going to be slightly above that. So just keep that in mind as we work through that. Okay, so here is our first example with a table. And so it says, does a table or rule represent a linear or exponential function? Explain. Well, linear means that we're going to be growing by the same amount every single time. For instance, we're talking about slope. So if we had a slope of 2 over 1, that means that every single time we increase our value of our y, it's going to be by 2. So 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth. Now these y values, however, though, we're starting at -1, and then we're going to 3, to 9, to 27. Well, just to kind of tie in a few things, 1 times 3 is 3, and then 3 times 3 is 9. 9 times 3 is 27. And so everything is being multiplied by an exponent of 3. So the base of that has to be a 3. Now, if we come down here, it shows that we're increasing by 1 between every single one, but we're also increasing by 3 times 3 to get to the next value. Okay? So I want you to see the difference between exponential and linear. Remember, linear, they would all be the exact same right from each other. Exponential, though, we're increasing by multiplying with an exponent. Okay, now this is probably the best visual that I'm going to have for you. So it says, the figures below are stages of the Sierpinski triangle. In stage 0, there is one black triangle. In each subsequent stage, a white triangle is added to the center of each black triangle. Okay? By dividing the triangle into 3 black triangles and 1 white triangle, the number of black triangles increases by a factor of 3 in each stage. So let me just reiterate what was just said. Stage 0, there's 1 black triangle and 0 white triangles. Stage 1, we put a white triangle right in the center of the black triangle, which created 3 more black triangles. Then I have my original white triangle in stage 2, and then I took my other 3 black triangles and put another white triangle in the center. And I continued repeating that pattern over and over and over. So as you can see, we're not increasing by the same amount every single time. We're increasing by a much faster rate. Well, logically, that makes sense, though, because we're increasing with a variable exponent, not a variable multiplier. So if we keep going down, we've got the formula, f of x, which means y, equals a times b to the x power. Okay, so we're going to substitute in 3 for b. And the reason that we're substituting in 3 for b is because right here, when we put in 1 triangle, it gave us 3. So that's where we're getting that answer from. The original base formula, change it to 3. Okay? And so then now every time that we do that, depending on what stage we want to put in, is going to determine what our value of our exponent is going to be. So for stage 2, we'd put 3 to the second power, stage 3, so on and so forth. Okay, we're going to move on to problem number 3. This problem, it says, suppose 30 flower beetles are left undisturbed in a warehouse. The beetle population doubles each week, and the function is 30 times 2 to the x power gives the population after x amount of weeks. Okay, so right here in this equation, our a value 30 is always going to be our starting point. That is our initial value. That's what we're starting with. So just like back in the triangle one, when we looked at our a value, we started off with 1 black triangle, which is why our a value is equal to 1. So back over here, a value is going to be our initial, okay, which we're starting off with 30. And then it says they double each week. Well, we know that doubling something means to multiply it by 2. And then it says, gives the population after X amount of weeks. Well, it tells us that 56 days is what we have, but we also know that days, there's 7 days in a week. So we divide 56 by 7, we're going to get 8. So it's going to be 30, our original amount, doubled over 8 weeks. And the reason that we have to do it this way is because every week we're going to have more beetles than we originally started with. So week 1, we started with 30. Week 2, we're going to have whatever 2 times that number is, so forth and so forth. Well, 2 to the 8th power is going to be 256. So 30 beetles times 256 is going to give us our total amount, and that's why this is our exponential function. All right, this is going to be the last one I show you today, y'all. And so what this one's doing is this one is just showing you what happens when you have a negative exponent. So we're going to just focus on this table real quick. It's telling us that the x value is -2. So that's where I'm putting my -2 into the x value of the equation. So 3 is my initial point, times 2, which is my b value, x to the -2nd. Now, because we're dealing with a negative exponent, we know we cannot leave it in the numerator. We have to flip it to the denominator, which becomes 2 to the 2nd power. And so what this does is when you're solving for the value with x here, 2 to the -2nd becomes 2 to the 2nd on the bottom, and then you end up with 3 over 4, so your y value is 3 over 4. Right here, -1 is my exponent. Got to put it over here, drop it down. We get 3 over 2. Well, 3 over 2 becomes 1 1/2. 0, 3 to the 0th power. Well, anything to the 0th power is going to be 1, so 3 times 1 is 3, giving me the y value of 3. And as you can see, the table just keeps going that way. So what I'm going to do now is I'm going to kind of wrap this up. I'm going to turn it back to me for a few minutes, and then I'm going to let it be. Okay, so by far not the best video. It's a difficult topic to talk about. I just wanted to get something out there so you guys are kind of aware of what's taking place coming up next week. So with that being said, I'm just going to recap a few things. The formula is going to be y equals a times b to the x power. Y and x are still representing points on a coordinate plane. The a value is our initial value. It's the starting point. How many triangles did we start out with? How many beetles did we start out with? Whatever the situation is. B is what the multiplier is. So B is going to be, is it doubling? Is it tripling? Is it increasing by 1,000,000? Whatever it is. And the x is going to be the amount of time. So let me just recap those three one more time. A is the initial value. B is the multiplier. And x is going to be your amount of time. A, initial value. B, multiplier. X is your amount of time. So if you understand those three things moving forward, I'm happy with it. Second part, this is called an exponential function because the focus is on the exponents, meaning that everything is going to increase at a very, very, very fast rate. We're not going to be increasing by consistent points like we do with linear, and we're not going to be increasing by asymmetrical points like we do with quadratic, okay? What we're doing is we're growing at a very quick rate, so just be aware of that. And the final thing I want you to understand about this is what an asymptote is. An asymptote means that our line is going to get really close to either the x or the y-axis to the point where it looks like it should pass through and become negative or positive, but it will never pass that point. Hey, thank you guys for being patient during this time. Sorry the video is not great. I'm just trying something different with the exponential. Be good. Have a great, great, great rest of your day. Fill out the Google form, and we'll pick back up with this next week. Peace out, y'all.